Okay. Sorry, 127. 127. 127. So what we're doing today is looking at the system of numbers called the complex numbers. Okay, complex numbers. And again, you guys have learned about systems of numbers probably since elementary school, right? The very first system of numbers you guys ever talked about, and maybe you didn't know it was a system, was the natural or counting numbers. And those are like when you 1, 2, 3, so on and so forth. I think if you throw in 0, now you're talking about the whole numbers. And then if you throw in the negatives, you're talking about integers. And then when we throw in like fractions, or numbers that can be written like fractions, you're talking about rational numbers. And then you're talking about things like square root of 2, which can't be written as a fraction, and its decimal goes on forever and never repeats, or like the number pi also. That's called an irrational number, right? And then all of those numbers together, what's that? Yeah, but just a little bit. But just a little, I'm just doing a little introduction here because we're building up to this. And then all those numbers together, both, whole, integer, rational, irrational, all those together are known as the real numbers, right? And then we kind of reintroduce the idea of the imaginary numbers, those I, right, for imaginary, because you're taking the square root of negatives. And if you take the imaginary numbers, which are a group to themselves, and the real numbers, which are a separate group, right? So you have imaginaries and reals, there's no overlap there. If you put those all together as one big group, you have what is known as the complex numbers, okay? So, what's that? In a way, yes. No, I mean, that's what mathematics kind of does. It seeks to, model, natural phenomena, I guess, and stuff like that. And yes, you kind of do create from the beginning of things and stuff. It's very, interesting, I guess, in some cases, but maybe not for everyone. Anywho, so the idea for us here is to understand what a complex number is, which we just kind of talked about a little bit, and then how we can add, subtract, and multiply complex numbers. Notice we're going to skip division for right now. We may come back to that. We're going to talk about just like adding and subtracting. Okay? So, what I would like you guys to do here, okay, we're going to have you do this explore right here, okay? So, in this lesson, you'll learn to perform operations with complex numbers, which have a form similar to linear binomials, such as 3 plus 4x and 2 minus x. Okay, so complex numbers are similar in form to these kind of binomials. Okay, binomials because they're 2, right? Linear because they're just like straight lines, right? So what I'd like you to do for letters A, B, and C is do the math that they want you to do there. Okay, so for example, it says to add the binomials 3 plus 4x and 2 minus x. So it tells you to group the terms. You're going to start with that, and you're going to rewrite things so that they're like grouping like terms, and then you're going to write the answer. If you just want to write the final answer, that's fine with me too. You don't have to like do the intermediate step. Same thing here. If you want to then do the subtraction, please. Notice it says to rewrite it as addition, all right, and then combine like terms and get your answer. And then finally, letter C, go ahead and multiply the binomials too. Again, they suggest use FOIL. Okay, so go ahead, A, B, C, give those a try. All right, try to remember those skills from another class. Okay, go ahead and fill those out. Take like a minute or two and fill those out. Okay. So give those problems a try on page 127. Try A, B, and C. We don't mind. Try A, B, and C. Get those done for me. Thanks, Tom. Try that A, B, and C. 127. A, B, and C. And you don't have to fill in all the blanks. If you can just come up with the answer at the end, that's fine. You don't need to worry about filling in all the blanks, because I think the blanks can be more confusing sometimes than helpful. Like 1 more minute, 2 more minutes, something like that. Try to finish the rest of these up. Okay. Call some people. Wow, it's a springtime party. All right, let's go to Jake for letter A there, Jake. What? Okay, so did you try anything, or do you have what you think might be an answer? Okay, so the idea here is we're going to add these two binomials together. So we just add this plus this. Okay, so well, what if you're going to take this and add it to this? What does it look like could go together there? Yeah, and what's 3 plus 2? 5, you got it. Okay, what else goes together? And it's a minus x, so that means we'll be left with what? Yeah, just 3x, exactly. 4x, take away an x is 3x, you got it, and that's your answer. Okay, the blanks here, the idea is that, did this part throw you off? So the idea, when it says group-like terms, or that, it's kind of like what you did mentally, right? You knew that the 3 and the 2, you group them together just in your head. What they want us to do is like say, oh, now we're going to do 3 plus that 2, and then 4x plus the negative 1x, because it's negative x. That's it. Yeah. Make sense now, though? Yeah. Yeah, good. All right, so let's go to letter B then. Any other questions actually on letter A there? We're all good? Okay, so let's go to Eve. Eve, letter B, please. What? So here we have an extra additional step. If we want to take this and subtract it from the 3 plus 4x, so that's 3 plus 4x minus the quantity 2 minus x, we want to rewrite it as addition. So rather than subtracting this quantity, we make it addition, and you can see we made this positive 2 and negative 2, and so this minus x should become a plus x. Very good. And then again, just like Jake did in his head, right, we're going to do it on the paper here. So the 3 should add with what other term here? The negative 2, right, okay. And then the 4x adds with the what? Right, it's positive x after we did our little work there. Yep, okay. And so what's 3 plus negative 2? 1. And 4x plus an x? Very good. And there it is. Okay, very good. Questions on that one? Easy peasy. All right, let's go to someone who's here. Oh, we haven't heard from yet. Patrick, letter C. Multiplying the two binomials together. Okay, so are you familiar with using FOIL, Patrick?
I don't really remember.
Okay, I'll help you some. So we're going to multiply these two things together. Okay, so FOIL is an acronym, right? It stands for first, then outer, then inner, and then last. So it's just kind of it's to help us organize what needs to multiply with what, right? So the FOIL, the F, is for first, and so 3 is the first term, and then 2 is the first term there. So 3 times 2 gives us the 6. So there's that's already done for us. Okay? Then we're going to multiply the outer terms. So that would be the 3 and the negative x, because they're like on the outside. So that's where we get the negative 3x from, right there. Then, so I'll put the O right there above it. Now we have to do the I term. So that's the inner. So if 3 and negative x were on the outside, then the 4x and the 2 will be on the inside. So what's 4x times 2? Yeah, 8x. Okay, good. And then the L is for last, and so that's going to be the 4x and the minus x. So what's 4x times negative x?
4.
Negative 4, and then x times x is x to the second power, 2. Yep, so negative 4x squared. Okay. Now if you notice here, the directions say, which you can't see, it says combine like terms. So what like terms do we have to combine here, Patrick? What goes together?
The negative 3x is negative 4.
So, you're right, the negative 3x will go with the 8x, right. Those do not go with the negative 4x squared because why? Why can't we put the 8x with the negative 4x squared? Why aren't they like terms?
Because of the square.
Yes, exactly right. Very good, Patrick. Yes, so the negative 3x and the 8x, they are like terms. That adds up to 5x. Negative 3 plus 8 is 5. And the negative 4x squared is just coming along for the ride. And there it is. Okay? So, those kind of skills, if this makes sense to you, or if now it makes more sense to you, right? If you can do this, you should be fine with what we're going to do today, because it's the only real difference is going to be that we are going to, you can turn the page here, the only real difference is going to be that we're going to replace those x's with i's. Okay? So, a complex number, let me zoom out here some more, there we go. Okay, so on the next page, or on page 128 now, a complex number is any number that can be written in the form a plus bi, where a and b are real numbers, and the I is equal to the square root of negative 1. Okay? So for a complex number, a plus bi, a is called the real part of the number. Now, that makes sense, right? Because there's no I with it, so that would be the real part. And then the b is called the imaginary part because it's next to the I, which is the imaginary, number. Okay? Anyway, so there's like a Venn diagram. So here are some examples of real numbers. Here are some examples of imaginary numbers. And then in the whole thing, so complex numbers includes both real and imaginary numbers. So like 3 plus 4i, 4 minus 2i, 1 minus I square root of 5. Those are complex, okay? Complex numbers. All right. We don't need to do this, okay. Yeah, that's okay. So, yeah, we'll talk about that. So in example 1 here, it says, identify the real and imaginary parts of the given number. Then tell which of the following sets the number belongs to. So does it only belong to the real numbers, does it belong to imaginary numbers, or does it belong to the complex numbers? Okay, so looking at A, the real part of 9 plus 5i is 9. So this right here is the real part. Okay, and the 5 is the imaginary part. Okay, and so since this has both real and imaginary parts to it, it's a complex number. Okay, and it's not just real, it's not just imaginary, it has both, so it's complex. It's a complex number. Okay. Looking at letter B, what's the real part here? 0. There isn't one. Exactly right. There is no real part, so we're just going to say 0. The real part of negative 7 is 0, or negative 7i is 0. What's the imaginary part here? Negative 7. For whatever reason, they don't include the I when they're talking about the imaginary part. They just talk about the coefficient, so -7. Okay. Because the real part is 0, the number belongs to these sets. So, since the real part is 0, it's not in the real set of numbers, but it is in the imaginary set because it has just an I, and also the complex as well, because if it's in the imaginary set, it's definitely in the complex as well. Okay, so go ahead, take 2 seconds and identify 4 and 5. So in 4 and 5, on the your turn here, so you have a 4 here on the bottom of the page and then 5 at the top of the next page. Identify the real and imaginary parts of the given number, then tell which of the following sets the number belongs to. Does it belong to the real numbers, the imaginary numbers, and or the complex numbers there? Okay, so go ahead, try 4 and 5 there on page 128 and 129. Okay, try 4 and 5. Try 4 and 5. And I can kind of come around and help too if you need some help questions. Okay, so try 4 and 5. Remember, 5's on the next page, so give this a try.
I use restroom.
Are you okay on this?
Yeah.
Then go ahead, yes. Okay, try 4 and 5. We're on the next page there, Connor. If you want to turn the page, please. Okay. On the next page there, Josh. Try the next one. 4. On the next page there, too. Okay. 4 and 5. 4 and 5. Again, don't identify the real part. But 4 and 5. One more minute. Shouldn't take too long. Identify the real parts, identify the imaginary parts of those numbers, 4 and 5. Okay. So let's see here. So number 4, Connor, what is the real part of this number here, 11? Yeah, it's 11. Yeah, exactly right. Yeah, that's the real part. Okay, what's the imaginary part? It's kind of a weird question because there isn't any imaginary part there. Okay, so there's no imaginary part, right? There's none. Okay, no imaginary part. Okay, so since there's no imaginary part, can this number be imaginary, Connor? Yeah, no. Is it real, though? Yeah, so it's real, and since it's real, it's also part of the complex number system as well. Remember, the reals are in the complex number system, so it's both real and complex. Okay. So the real part's 11, the imaginary part, there isn't one, and so it's just real and complex, but not imaginary. All right, next one here. Thank you, Connor. Let's go to Miranda. Miranda, what's the real part of this number? Very good. The real part's -1. And what's the imaginary part? Yeah, it's like the 1 in front of the I there. The imaginary part you'd say is like the 1 I there, 1. Okay, good. So, is this number real only? Is it imaginary only? No. So the best we can say then is it's just complex. Okay, because it has both real and imaginary parts, it's complex. We can't just say real, we can't just say imaginary here, because it has a real part, but then it also has an imaginary part. So the real part makes it not imaginary, the imaginary part makes it not real, so it's just complex. Okay. Questions on any of that? Alright, so let's get into some arithmetic here. Alright, let's look at the arithmetic and then we'll talk about multiplication. So, arithmetic. To add or subtract complex numbers, add or subtract the real parts and the imaginary parts separately. So guess what? It's combining like terms. That's all it is. Alright, if you look here, if we want to add the complex number -7 plus 2i, we want to add that to the complex number 5 minus 11i, all you do is combine like terms. So the -7 is like with the 5, so -7 plus 5, -2. And then 2 plus -11 is -9. So you get plus -9i. And you can leave it like this if you want, -2 plus -9i, or you can change the plus -9 to make it just minus a positive 9, like that, I. And that's all you got to do. That's it. Okay? So like for letter B here, okay, we're going to subtract, but since we're going to subtract, let's change it to, plus, and then we'll make all these things in here the opposite. So it'll be plus -2 plus -3, okay? We'll just distribute that minus sign. And now we're just going to combine like terms. So what's 18 plus -2? Anybody? 16, yeah. And what's 27 plus -3? 24. And don't forget the I, right, at the end. And there it is. You just combine like terms there. That's all. Okay. All right, so let's try 7 and 8 here. I'll just call in some folks here. I won't make you guys do the whole thing on your own. We'll keep it rolling here. So let's go to David. So David, we've got some subtraction here. So instead of subtract, we're going to change it to add, and then we'll just make these opposite. Yep, distribute the minus sign there. Okay, so what are some like terms you can combine together here? Okay, so let's do the constants first. What's 17 plus -9? What's that going to give us? 8. Okay, and then how about the -6? -16? Very good. That's all you got to do. Combine like terms there. Very easy. All right, let's go to Jordan. Number 8 there, Jordan. It's addition, so now we just need to combine like terms. So what are our like terms to combine here, Jordan? And what does that make? 8, you got it, very good, yep. And then what other like terms we have combined? Yeah, it's a minus 12i, right? So what's that going to leave us with? Very good. You guys got it, yeah, that's it. There we do. Combining, adding, and subtracting complex numbers. Easy, easy, easy. All right, last thing we got to look at, we said we're going to talk about multiplication too, right? So here's multiplication. To multiply, we have to FOIL. Okay, to multiply, we have to FOIL here. So, here we can see 4 plus 9i times 6 minus 2i. All right, so we can, let's see here, 4 times 6 will give us the 24. There, okay. The outer, -2i times 4 is -8i. There's -8i, the outer. The inner, 9i times 6 is 54i. And then we have 9i times -2i gives us -18i squared, right? Because I times I is I squared. Okay. But now here's something interesting. That I squared, notice it says substitute -1 for I squared. Well, why can we do that? Why can we do that? Why can we substitute in a -1 when we see an I squared? The I means what? Not negative 1. It means, yes, the square root of negative 1. So, if we have I squared, well, that means we have the square root of negative 1 squared. But when you square a square root, what happens? It's gone. It's now just negative 1. So when you square the imaginary number I, it becomes real. It's no longer imaginary. When you square it, it becomes real. It's no longer imaginary. So this 18I squared, this minus 18I squared is really minus 18 times negative 1, which then makes it plus 18, which you add to 24, and that's where you get that 42 from. Okay, so the negative 8I and the 54I, they're just going to combine together to make 46, right? 54 take away 8 is 46. But 24, you're going to add, because again it's 18 times negative 1, so it's going to be plus 18, so 42. Okay, so let's try that with this one right here. I'm going to ignore all these blanks. I don't like filling in those blanks. They're a bunch of junk. So we're going to multiply these two things together. Okay, so let's go to Carlos then. So Carlos, to multiply these two things together, do you like using FOIL?
Oh, yeah.
You're fine with that? Okay, so first, what are we going to get? What are the first things? Yep, so that makes negative 21. Very good. Okay, and then the outers? No, you're right. It's negative 3 times 4I. So what's that?
12I.
Minus 12I. That's okay. And then the inners? Ooh, 7 times 12. Okay. Yeah, you're right. Yeah, very good. It's 84. Well done. And then the lasts. 48I squared. Very good. Okay. And so, again, let's combine the negative 12I and the 84I. So we have minus 21, let's see, minus 12 plus 84, 72I. And then plus 48, but no longer we're going to write I squared. Instead of I squared, we're going to write what? Negative 1. Yep, you just flip the sign basically. And so it's negative 21 plus negative 48. So it's going to be negative 69 plus 72I. Okay, and there's our final answer. And please, folks, I know it's like, I don't want to say it's silly, but it's like, this is what we do. You normally put the real part first, the imaginary part second. Okay, so please don't put, the I stuff first and then the real part. It's only real, then imaginary. Okay, so, all right. So let me have you guys just try one of these here real quick. So you guys pick 10 or 11, either one there. Just try one of those. If you want to do both, but you only need to do one. Okay, just try one. 10 or 11. Pick one and try it real quick here. Okay, and then we'll go over them. I'll give you guys your assignment. However you like to multiply and find Just pick one of those to do. 7 or sorry, 10 or 11. 10 or 11. Are you all done? Okay, can you finish up real quick and then I'll let you go? And you can just go as soon as you're done. Don't worry about sticking around for the answers if you don't want to. Just finish up the problem real quick. All done? Okay, so I think that should be it then. The first page? Oh, okay, I didn't realize that. Okay. So, you're right, I see that now. Okay, there you go. All right, Andrew, which one do you want to do? 10 or 11? 10? All right. So, FOIL, right? First, outer, inner, last. So, if we multiply our first two numbers together, what are we going to get? What's that? 6 and the 3, yep. So that's what, 18, okay, good. And then the outer two numbers, so that'll be the 6 and the minus 10i, right? So, minus 60i, very good. And then the inners, minus 15i, very good. And then the last. Positive, right. 50i. It's I times I, so that should really be I to the 2, or squared. That's right. Okay, good. So let's see here. We can combine some like terms. We have 18, but the minus 60 and minus 15 make minus 75i. And then I squared is the same as what value? Andrew? Not sure? What's I squared equal to, Connor? Negative 1. Remember that I equals the square root of negative 1, right? That's why we use I in the first place, to represent the square root of negative 1. If you square I, you'll also square the square root of this. You'll also square the square root of negative 1, so it's just I squared is negative 1. So this plus 50 becomes what then? Minus 50. So 18 take away 50 then is going to be negative 32, I think. Whoops. Minus 75i, or you can say plus negative 70. I guess technically it should be then plus negative 75i at the end there. Okay. So there it is. Did anyone try 11? Anyone try number 11? Everyone did number 10? You did 11? Okay. So I'll run through that one here real quick. Just the first will be 88. The outer will be 8i. The inner will be 165. What is it? 165. Okay. And then a plus 15i squared. And so let's see here. So it'll become negative 15. Well, I'll just do it this way. 8 plus 165 is 173i minus the 15 now. And so we get 73 plus 173i. Well, that's kind of interesting. Coincidence there. Okay. So there's that. Questions on any of that? Easy peasy? Hope so. All right. Here's what I would like y'all to do then. How about numbers, page 133. I'll have you do 3 through 17, the odds, please. So page 133, numbers 3 through 17, the odds. Okay? Yep, that should be good. Alright. I'll leave this up here for you if you want to check your answer there, Jake. There's 10 and 11, and then there's the assignment on the board there for you, too, so you can see that. Okay. Well done. All right. Thank you, Emma. No problem. Try and get this straight and back to you by tomorrow, okay?
All right, thank you.